Thank you. Thanks for joining me, everyone. Like I said, my name's Greg Shackles I'm principal engineer up at Olo in New York. This is all my contact information, but honestly, I'm very easy to find online. I mean, if you just ping me on Twitter or my GitHub account, all the code for this will be live just after this because I forgot to hit publish before. But the slides are already up and everything, so basically everything's available, and I'll tweet about it right after this. But I'm going to stop wasting time talking about myself because we have a lot of really cool stuff to chat about. So if you were in the keynote earlier, and I hope you were, there was a lot of discussion around kind of the whole life cycle of things, right? So you start and you build an app and you test it, hopefully. You prepare a release, you get it out there. But what I really want to talk about with everyone today is what happens after you push it out there, right? I mean, you have these thousands or millions of copies of your app kind of running wild. But do you really know what's going on in those when they're out there? And I mean, I'm probably the only one that writes bugs, so I mean, really, everyone's probably having a really good time in your app anyway, right? Like, you really probably don't have a whole lot to worry about. It's just party central, all day, every day. But I mean, maybe that's not the case, right? I mean, maybe users are getting kind of frustrated. Maybe they're running into errors, or they're hitting exceptions or crashes and whatnot. I mean, it's a possibility, right? Work with me. Maybe it's not crashing, though. I mean, maybe it's just really kind of confusing, and something that seemed sort of obvious for you when you're developing the app isn't quite as obvious, and users are sort of, hurting themselves, hopefully not quite like this, or maybe they're just not getting the value out of it that you really wanted to deliver, because it's not quite as obvious to them as it is to you. Maybe none of those things are happening, but it's just really, really slow, and one of the most frustrating things an app can do is just be really, really unresponsive. So maybe eventually, if they're really, really patient, they'll accomplish what your app kind of set out to do. But they're probably not going to have a whole lot of fun if it's anything like this. But really, what all this sort of boils down to is that, unless you can answer these questions, unless you really know what's going on inside of your app and you have the actual data to go with it, not just anecdotal stories or bad reviews or anything like that, but unless you really have this kind of data and this kind of insight, you're effectively flying blind. And that's a really, really bad place to be, especially in the app world where, you don't want to find out through app reviews if something sucks, right? So quick show of hands, who here is doing crash reporting in their apps? Okay. Who here isn't doing crash reporting in your apps? Okay. No? Well, a little shame. But hopefully I can convince you that it's really, really easy. Who here is doing any kind of analytics? Okay, so a lot. Cool. So hopefully I don't kind of repeat a lot of things that you know, but what I do want to kind of talk about is we'll start off with the kinds of things that you can start measuring and the kinds of things you can start getting real deep insight into as you start taking a look at these things. And we'll start off with what I call standard issue metrics. These are the things that any analytics platform out of the box probably has reporting on for you. You don't even have to really think twice, right? I mean, the most obvious thing is screen hits. So I mean, especially if you've done analytics on the web world, screen hits, page hits, whatever, these start to tell you, what pages or screens users are using in your apps, what kind of flow, how do they get to and from these different areas. Really, really important data, but this is really as basic as it gets, right? And you can start slicing things up so you can get your operating system version, so your iOS or your Android or your Windows versions, the specific version of your app, the device type. So this is especially on the Android world, but even on the iOS world where there's a lot more than they used to be. I mean, this is really, really key stuff to know. And then things like, well, how long are users spending inside of your app? Are they coming in really quickly, getting frustrated? Are they spending a lot of time? Or maybe they're spending a lot of time and your app is meant to be really, really fast. So all these things have to be within the context of your specific app. But if you can't answer these things, you're putting yourself at a real disadvantage here. So those are the really, really basic things, right? But I want to start taking some steps beyond that to talk about what I think are more interesting things you can start paying attention to. And when I set out to do this in a lot of the apps that I was working on, this became the fundamental thing that I really wanted to answer. How long were users spending waiting and watching a spinner like this, which is a bad app experience? How long am I making them wait and stare at spinners when they really just want to be moving on to the next thing. They really just want to be accomplishing whatever it is that particular app is setting out to do. So this became the main question I set out to answer, and then it was just a slippery slope beyond that. But just like one quick note on that too, and it's not just a nice to have at this point, honestly, like fast apps, responsive apps, these are things that users rate at the top of their list of things, expected features. So these aren't, just differentiators. They're expectations at this point. So users expect this, and, there's a pretty good chance that for whatever your app is, there's some alternatives in the App Store as well. So you don't want to give users a reason to start trying out alternatives once you get them, because you have very few opportunities to really hook users in and get their loyalty and get them to keep coming back to you. So one of the things you can start to take a look at is network performance, right? Like obviously on mobile devices, network is a really, really big deal. So some obvious things you can think of there are things like the request duration. How long are these requests taking to go to the server and come back? And one of the reasons why this is really important to measure from the device itself, from the app itself, is that, and especially in my case, like I already knew, I had a really good idea what our server response times were. I mean, we have all sorts of tooling on that side. We have tools like New Relic and Datadog, which I'll show later. So we know how our server's responding, but when you put these devices into the mix, and you have to start dealing with the latency from these mobile networks, you have to start dealing with all these other factors that go on. And the user doesn't really care how long your server has to do with it. They care about the whole round trip that has to happen here, right? And that's where it becomes really, really key to start measuring it on the device. And then continuing on from that, how often are these requests failing or succeeding? Do you have to keep making them over and over before you eventually get the right answer? How frequently are you making just requests in general? Should you be caching? That's why it gets really, really important just to start looking at this. And going back to the mobile network side of things, and you also have to remember that you're dealing with users that are potentially on the go. They're on their metered mobile networks. You don't want to be the app that just sucks away all their bandwidth, right? So you want to always be conscious of this stuff, one from a performance perspective, but also just from a user experience and wanting to keep users around kind of perspective. And continuing that as well, like it's good to know the types of networks that your users are on. I mean, the one thing that I'll come back to a lot is starting to gather this data is important because it teaches you what your actual set of users are using, right? Like you can look at reports that say, oh, well, in my demographic, in my area, users are using X, Y, and Z. But once you have the real data that goes behind that, you can start targeting the reality versus what it's supposed to be, and that's really, really important. But let's go beyond network performance for a little bit. Like, what are some other performance aspects that we can start taking a look at for apps? And a really key one is what I like to call time to interactivity. So in my head, this is basically how long does it take from the moment that user taps the icon on the home screen to the point where they're able to interact and start doing whatever it is that they kind of set out to do there. So this will take into account things like your app startup time and bootstrapping time. Do you need to go download stuff ahead of time, or can you do things in the background? Can you already have whatever you need cached and ready up front so the user can just kind of get going right away? Really, really important stuff. Memory usage, obviously. Like these devices are not developer desktop workstations. They're getting really, really a lot better year after year, but they're still not powerhouse server machines, and you're sharing that space with a whole bunch of other apps and system things going on. So it's always really important. Along the same lines, battery usage. Operating systems, iOS and Android all shame apps now. So you don't want to be the app at the top of the list when a user goes to ask Android or iOS, like, hey, why is my battery dead by lunch? Like, you're going to get uninstalled really, really quickly there. Things like database calls. So similar to the network stuff, if you're doing database stuff within your app, you want to know how long that's taking. Maybe you're doing too much work there, or it should be done in the background. Again, you just don't know this stuff until you start measuring it. And then you can start introducing caches, and then that kind of ties together all these other things, right? So a cache will prevent you from making too many network requests, but maybe if you're watching when caches hit or miss, you'll know whether you're just wasting memory and battery and all that kind of stuff for caches that don't actually help. So the moral of the story that I'm going to obviously keep hammering on is just measure everything so that you know what the actual truth is. Like that's what this all kind of comes down to. But let's go beyond actual performance, right? Like, so that's hopefully that part's pretty clear and agreed upon. But there's a lot more that we can do as far as analyzing and monitoring these apps that goes beyond raw performance and gets into like how your apps are being used, like how users are interacting with your applications. So this comes down to user behavior, and this is where it gets a lot more interesting, and it gets a lot more nuanced to your particular app and your particular domain that you're servicing here. And it's where you can start defining what has meaning, like what has semantic meaning as a metric within your application, right? So a lot of the more obvious ones that come to mind are any critical flows within your application. You can start seeing how long users take to get through those, and you can start trying to decrease that time to increase their happiness within your app. An example, like I work in e-commerce for a lot of applications that I build, so like we look at things like cart abandonment rate, or how long it took to, the critical flow would be how long it took to add an item to a basket and complete an order, and you always want to start minimizing these things. So again, if you're not monitoring, you're just not going to know. And you can also start to monitor specific actions within an application. So kind of going back to what we were talking about before of like you are not necessarily your user. So a lot of this comes down to just empathy and understanding, like, and wanting to understand your actual end user and what they're using. And just because you think a feature is really, really awesome, or this new thing that you built is really cool, doesn't mean that other people are going to necessarily start using it, or maybe they couldn't even find it. So unless you're measuring, when these different events that have some sort of meaning are happening within your app, you just don't know. And we'll get into a little more of that now. So I mean, are they using that new feature that you really, really love, or are they sticking with the old version that you're trying to get rid of? Is it along those same lines? Is it actually safe to remove that stuff? You don't want to find out through app reviews that users were really, really hung up on some particular feature that you just yanked out of the app. But if you have stats that say no one's really using that anymore, you don't have to. You could pull that out. You can stop maintaining that code. You can stop testing it. So that's really, really nice to be able to point to data to back that kind of stuff up. And across releases is when this really gets powerful. So once you have this backlog of data kind of coming in, you can start to track it across release 1, 2, and 3, and you'll know if things are getting better, you'll know if they're getting worse. You can line things up with, I launched feature X and it resulted in a bump in some metric. So the ability to like track these things over time once you have that baseline of data coming in is where it gets really, really powerful. And you can even take that a step further and start doing things like A/B testing then. So again, once you have this backbone of data that you can kind of fall back on, you can start tweaking things. And one of the canonical, like really trivial examples of A/B testing would be imagine that you kind of split your users into two groups, and you changed a button color from like blue to green, and then you started measuring the impact that might have on all these different other metrics that you're already collecting. And maybe you discover that it should be blue or it should be green. But you can start doing really interesting things once you have this data coming in. So that was a lot of the what and the why. And I want to spend the rest of the time here kind of talking through how you might kind of go about doing this. And there's a million solutions out there and a million products. What I kind of want to go through in the demo today are a few products that I personally really love. None of whom give me a paycheck or anything, so there's no, whether you use them or not doesn't impact me personally, but these are things that I use personally every day, in my own stuff and the stuff that I'm doing at work, just to show that it's really not that hard to kind of get started measuring this stuff, and it can be an incremental scale. So you can start with the simple and start layering in things as you get there. It doesn't have to be a big bang kind of thing. But as long as you start to really pay attention to these things, like that's what truly matters, regardless of which products you end up using. So don't get too hung up on these specific products, but if you think they look cool, definitely check them out, because I obviously like them. So the first one we're going to take a look at is Hockey App. And if you hadn't heard of Hockey before you came to Evolve, you've certainly heard of it by now. If you've used Insights before, then Insights is being rolled into Hockey App, and they're becoming one product. And Hockey App does everything from crash reporting to analytics stuff that they're starting to roll out, to beta distribution, and a lot of really cool application lifecycle and management stuff there. So we're going to take a look at that and how easy it is to add crash reporting, which I said it has to be your baseline. Like if you don't know that your app is crashing, you're in pretty bad shape. I'm going to take a look at a service called RunScope that is a really, really nice set of tools for API development and API testing. Because it's easy to kind of forget about it or gloss over it when we're talking about mobile applications, but there's probably some sort of API or set of APIs that your app is talking to. And if that's the case, then if those go down or if those are throwing errors or something, then your application might be useless. So it's really important to keep an eye on all of those APIs that you depend on and that you run as well. Then we're going to get into a service that I mentioned before called Datadog, where we can start kind of rolling our own basic metrics and instrumentation, and I'll show how to slice and dice those in real time in a whole bunch of different ways. And yeah, if you end up thinking that Datadog looks cool, we should probably chat afterwards, because I could probably talk about it for a full day. But it's a really powerful system for taking metrics from all sorts of different things, so from servers and custom things that you put in there to your Azure queues to whatever you might have, and be able to build out dashboards that show whatever it is that you need to show and become like a real life support system for your apps and a real pulse for your apps. And for all of these, I want to show that it doesn't have to be like a one-way street. So it's really easy to sign up for a whole bunch of services like this and then suddenly have a huge set of dashboards that you have to start logging into and refreshing all day, and it becomes super time-consuming. So you can set up basically all of these tools out there to start reporting things back to you and make it a little more of a two-way street. So for each of these services, I'm also going to show how to make that more of a bidirectional line of communication. And now I'm going to get out of PowerPoint before I run out of time. OK. So what I want to do is I wrote up, I have a really simple demo app here that I have on iOS and Android, and I definitely could have benefited from some of the nice theming stuff they announced this morning, but I wasn't brave enough to change anything in the last 3 hours. I take pull requests once this is public. But the design of this hopefully shouldn't be a sticking point. But the basic idea of the app is that it's a basic search box where I can type in a company name. So if I type in Xamarin, then it does a company search, and it'll pull up the logos for them. I can tap through on the company, and then it's going to load the web page that it gets back for that company. So if I do that, I search for Microsoft. We can do this. We get some results there. Let's see, if I search for Olo, the company I work for, well, that's not really that good. So let's see if that's happening. All right, so we have a crash here that's happening on iOS and on Android, right? So in order to find out what's going on, obviously this is local, and I could be running, I could run it in debug mode and look at the logs and all of that. But let's take a look at what it would actually look like to get this crash reporting into Hockey App. So what I'm going to do is I already have an app set up for Hockey App, and I'm going to come in here and uncomment a few lines. And really all of this is doing is saying, configure it to a particular app ID, automatically send the crash reports as you get them off to the server. If you didn't set that, then all it would do is pop up a thing saying, there's one of the classic dialogues of, do you want to send this back to the developer? For the sake of the demo, we'll just do that automatically, and then it just says start. And if I look at the Android side, it's pretty similar in fewer lines of code. Well, spread out across a couple, but you just say the same thing. Here's my API key. I want to automatically send, and we're good to go there. So I'm going to compile this, run it again, pull that up. We'll pull that up on iOS here. I'm going to run the search. Sure enough, it crashes again. Pop open the app so that it reports back. And let's go take a look at Hockey App over here. So I'm going to refresh this. And you can see that we have one crash that came through. And I'll take a look at this. And you can actually see that a notification just came in here as well. So I'll jump over to the Slack channel. And you can see that over down here, we get this at Olo a lot. It's a company too awesome exception. I don't know if anyone else runs into this, but sometimes it just kind of sneaks into there. Terrible joke, I know, but I needed something. But we have this, and I can click on this too. I can come through, and you can see we have the full managed stack trace here, so it points kind of right at where the problem is, and you can see, okay, well, let's take a look at line 31 of search service. So I'll pull that up. And you don't need to worry too much about the specifics of how this app is put together. It's a really simple service with a couple pages, and there's not a whole lot of magic there, but it'll all be open source. And sure enough, line 31 has the fateful line that our developers love to put in there. So we'll get rid of that, sadly, and we'll run this again. And make sure that we fixed our crash here. So I can do that. That works. I don't know what that other stuff is, but clearly we should be the only result. But the real story there is just, with a couple lines of code, you get that crash reporting for free, and you get alerting, and all I needed to do is set up a simple webhook, and I got that alert coming into a channel that I would be paying attention to, right? And you can tune these things. It's really easy for alerts to get out of hand, and channels become nothing but alert spam, and then they get ignored just like anything else. So it really comes down to tuning, but you can start tying all of these things together so that your tools really work for you. And especially with the new stuff that Hockey launched just a few hours ago, where you have these nice managed stack traces, and you'll start seeing stuff like how many crashes per day, how many users were impacted, what were the impacted operating systems and devices and operating system versions. So you could see it, well, I'm crashing on Android 4.0. Hopefully, we're all starting to try and drop that stuff, but maybe you're still on it. But you can start to really see, like, maybe I have problems in this area or that area. Like, having that data is really what matters. So I want to move on beyond crash reporting. Like, I just wanted to show that it's super, super easy if you're not already doing it to kind of get going. And again, that should be your baseline for everything. So let's take a look at RunScope. Has anyone here used RunScope? Awesome. Hopefully I convert some folks here. So they have a whole bunch of tools that I won't really have time to show, but one of the things that I have set up is this API test. And what this is doing is you can set up, if you're familiar with any kind of test environment, so unit tests where you have a bunch of steps and you run assertions and that sort of thing, and you can do the exact same thing in RunScope, except you can do it for HTTP APIs and a bunch of other stuff. So what I have here, if I go to edit my test, and the network behaves, there we go. You can see I have some settings here. I'll go up here, and you can see I have one step, but you could do a whole series of steps. So like for our stuff at work, we have tests against all sorts of APIs that'll run through a huge, long scenario and make sure that everything's kind of going through okay and alerting us if it's not. And you can use the results from previous steps and following steps. And so you could really tie together a holistic simulations of running through API stuff automatically. But this one's going to be stupid simple. So we're making one GET request to this ClearBits autocomplete API, which is what's behind the demo app there. We're just saying query for Olo, and I'm going to have a couple assertions here. So when it comes back, we assert that return to 200 OK, and that the name, and you can do JSON parsing and stuff. So I'm saying the name of the first item in the list is Olo. So if I change this to be definitely not Olo, we'll save and run that. See, it's running right over here. You can see that it failed. That failure also reported into Slack here. So you can see that one assertion passed, one failed. If I went to view result, that's going to pull up this. You see Olo is not equal to definitely not Olo, which I think we can all understand is invalid. So I'll come back here. Let me just switch that back. We'll run this again. And we'll see that worked. So that reported into Slack again. And you can see the requests and the responses and stuff going out. So if something did go wrong, you'd be able to kind of inspect exactly what kind of went through the wire here and take it from there and really figure out what was going on. And while I'm in here, I want to show one other feature that RunScope has that it's kind of up to you whether you ship your apps like this. But what you can do, and if I pull open I'll pull open search service here, and I'll take this URL. So this is the base URL for the API that the apps are calling. And I'm going to feed it into this here. And basically, all this is giving me is a run-scoped URL where run-scope is going to act as a proxy for all the requests going out to this URL. And it's going to pass it on to the end URL that we wanted. But since it's going through that proxy, it can show us what went out in that request and then what the response was. And you could start really getting full details of everything that's going on there, which is really awesome for trying to diagnose problems that are going on in your HTTP APIs or someone else's HTTP API. Again, it's up to you whether you want to ship an app to production like this, especially if you have sensitive data or something going through. I wouldn't really recommend doing that. And you're also putting in a single point of failure that you don't necessarily control. But it has also been a really solid product for us. So it's sort of up to you what you want to do there. But again, so if I search for Olo here, that comes back. And then if I reload this page, you'll see that this request is here. So this is the one that just went out from the application. You could see that it was a GET request, query was Olo, and here's the response there. So that's the same exact response that the application's getting back and that it's parsing in the background there. So it's a really nice way to be able to inject debuggability and inspectability into HTTP APIs, especially ones that you don't control and you can't monitor on your own, which is certainly the case for this Clearbit one. So now what I want to do is I want to talk about doing some more custom instrumentation stuff. And this is going to be kind of a light version of some of the things that we're doing at Olo, where I mentioned that we want to slice and dice things in all the different ways that we want and define what's meaningful for ourselves in a similar system that we use for everything else. So what I want to show there is under here, and I won't spend too much time looking at the code here, and again, it'll be open source shortly after this session. But basically, I have this, what I call the metric service here. So you're going to feed it in metric objects that are just going to have some stats and metadata about whatever that metric is. It's going to queue them up, and then it's going to periodically flush those out. For the sake of the demo, I have it flushing every 10 seconds. I wouldn't necessarily recommend shipping an app that does that, because that'd be a lot of network traffic that you're wasting and battery and all that kind of stuff. But I don't want to waste everyone's time here with 17 minutes left. So, and that's basically all this is doing. So it's going to kind of keep flushing over and over as metrics are put into it. And then one other piece of code I want to show is this instrumented HTTP client handler. And what this is going to allow us to do is there anyone here not familiar with HTTP client, by the way? Awesome. So this basically just becomes a class that you could throw at the constructor to HTTP client, and everything's going to get instrumented automatically that goes through it. So you don't have to modify any other external code. It just kind of hooks into the send call that comes through, wraps it in a stopwatch, and then reports that API metric out. So you can start monitoring every single API call that goes through without having to do any extra work. And as a quick aside, when I was first implementing some of this stuff, I wrote up a quick app in Xamarin Forms that I used as a profiler that I pushed out to Test Cloud that profiled how expensive my profiling code was, because the other thing that you want to keep in mind is you don't want to degrade your performance so much by adding all this instrumentation to it. So it's something else to certainly keep in mind, but this ends up being essentially free, especially when tied to something like a network request that's going to take a whole bunch of time to go out. So in order to use this, all I'm going to do is come and take this HTTP client in here and do that. And then now we're going to be logging how long each network request takes that goes out. And I'm doing the same for the metrics call as well. So it ends up being kind of this fun situation where you're instrumenting the call that sends your metrics back to your API, which is a lot of fun. But it is good to know how often you're sending things back and how big those payloads are, because these are real requests. And then the other thing that we're going to do, just so we do this all kind of in one shot, is let's start monitoring some metrics as well. And as I mentioned earlier, like if you're using any of these other metrics and analytics packages, or if you're using Hockey App and they're rolling out basic analytics and all this stuff, like you could absolutely use that stuff as well. But since there are going to be some other sessions, throughout today and tomorrow on a lot of that stuff specifically, I wanted to show kind of some other options that are out there that are available to you for not a whole lot of money, honestly, that let you just really dice things up in any way that you want and without having to write a whole lot of code to do it. So as part of that, let's also log a couple events here. So when we come into here, let's log an event for, or a metric really, for every time someone searches, and we'll log what the search term was, and then we'll get a real-time look at what people are actually searching for. So I'm going to say, we're going to log, I'm going to do new. I'm going to give it a key of find companies. Just say 1, and then for tags, use some cool C#6 stuff, and I'm going to say that the query is query. And then I'm going to copy that, so you don't have to watch me type the same thing again. And then I'm going to come into pages here, and then on the search page, there's this callback here where when someone taps on one of the companies and wants to view it, so we're just going to use that as a hook in the code behind here and say, say view company, and then we need to switch this around. So we'll just log for now we'll just log the name of this, right? So we'll just say company.name, build to make sure I didn't do anything kind of weird. And then we'll just run this on the simulator again, trigger some events, and we can show that kind of coming through all the way down through the API, down to, in this case, I have a local instance of the Datadog agent running on this machine. And then it's going to get published into their system, and we can operate on it. So we can just kind of load this up with some data, do some searches. Let's see. That is not how you'd think after like 7 years in this community I could spell Xamarin, but clearly I can't in front of a bunch of people. So we'll load that. Let's say Microsoft seems appropriate. Say Zamasoft. Apparently that's a thing. I probably shouldn't ad-lib search terms on this. I don't know what'll come back, but turns out that's a thing. Search for this really cool app that some awesome people built, and I'm definitely not biased at all. So that should be reporting some stuff. There's going to be a few seconds of lag for it to come down to the API, a few seconds of lag to come up to Datadog. But if I come in here, you can see that some stuff is starting to come in. You can look at things like, I can look at if I looked at system CPU, this is actually the CPU usage of this machine that's right here reporting, because the agent is kind of collecting that over and over. But let's look at the evolve ones that we were doing. So if I do a search here, I could say, here's the average time that those API calls took to complete. And let's get a few more in there. We just repeat some searches so they start coming in as we're talking. OK. So this is the average there. And then you could start breaking them up by the tags that you're giving them. So in the case of API calls, we were saying we were sending through the local URL of the call that was kind of going out. You could split it up by operating system. So iOS and Android, I have it kind of splitting out separately, and you could dice them up that way. We could say 1 graph per call, and now we see the average for the metrics call and for the API search call. And you can start kind of like dicing these things up in any way that you want. So if I look at find companies, we could say, actually it's going to be find, yeah. But while we're in here, so you can also set up custom dashboards, and I could make that bigger because that screen is massive. OK, hopefully that's better. Here's kind of a custom dashboard that I threw together that just shows like a couple ways that you could start slicing the data up in really nice visualizations. So you can do things called top lists, where I say, well, I wanted to get a list in descending order of all the slowest API calls, and then you can pinpoint those as what users are spending the most time waiting for. And you can kind of cross-reference that with which ones are being called more frequently. And in this case, it's going to be metrics, because that's calling like every 5 seconds or whatever that was set to. So there's going to be a lot of those. But you could start to really break that stuff down and see what it is. And I can limit this down to the past hour. So this is not showing my practice run like an hour ago. let's see, so you get the top search terms here, and I might have had a typo in in companies viewed. But when you're editing these things, you get like really nice feedback as well. So I could say, as you're kind of doing this, and it's all kind of graphic, GUI based for editing this stuff, you get really, really quick autocompletes. You could take the medians and 95th percentile and all that, and you could do all that right through here, which is really, really powerful. And I promised that, actually before I jump into that, I can show, so when you're adding graphs, you can do query values, so you can have, like an example of like some stuff that we use at work is we'll show, the current number of requests coming in per second to the API, or the current number of orders being placed per second, like really fun metrics to watch, like when your system really gets going, but it gives you a good idea of the general health, or you could do it for your CPU value, or whatever things you want to be looking at, you can just expose in a really nice real-time dashboard. And you could slice it up over time. You could do, you could see, week over week or month over month kind of data as well. So whatever becomes useful. Heat maps are really nice too. And then the other thing, so there's a couple other things you can do here, and I don't want to show monitors, but that also kind of goes back to what we were talking about before of you could set up the system to alert you when things go wrong. So you could say, well, if my API response time goes above 500 milliseconds or a second, or like whatever a bad value is for your system, you can have it alert you, and that could alert you in a number of ways, and one of which could be the Slack channel or an email or sending a request out to a third-party service like PagerDuty or something. So again, you can start tying your services together and tying all of these disparate systems together to work for you as part of like a holistic monitoring solution, and that's where things get really, really nice to use. But I did promise some sort of Slack integration for everything that I showed. So let me take a look at, so we're going to jump over to here, and I'm going to come in here, and I'm going to invite my friend EvolveBot into the room. So EvolveBot is an instance of Hubot that is a project that GitHub put out that they use for a lot of chat ops kind of stuff and automation. So I have a couple integrations in there, but most importantly is one that I wrote a few months back that lets you query out from Slack or well whatever Hubot's running in. But that's a good thing to bring up too. Like none of these things are specific to Slack as well. So you could be using HipChat, you could be using any of these other chat services. I just happen to be using Slack because I like it, but you can tie together any sort of chat tool with this. You can even run Hubot from like the local command line or whatever if you want. So what we can do is I'm going to jump back into this dashboard for a second. And let's say we want to start exposing the average response time and the total number of API calls as graphs that can be pulled on demand into the Slack channel. So what I'm just going to do really quick is you can go over to the JSON tab here and get their query language version of the thing that you write. You would never really want to write this stuff by hand. You can write it through their UI and then just snag the JSON. And then I'm going to come over here. I'm going to say EvolveBot, Datadog, query that. And then there's a built-in pause, and not just to make me really nervous during a live demo, but because Datadog needs a few seconds. And it shouldn't be that big. So let's see. Hubot's not working. Of course, it works every time that's not in front of everyone. So I'm going to let that restart for a second, and then I'm going to pretend like that never happened. But anyways, I could speak to what we can do here first while that's kind of coming back up. But you can pull the stuff out of here, and then what this Hubot plugin lets you do is say, I want to query this query. I can save that. I can pull it up again. I can look at it over, say, 15 minutes, an hour, 2 days, a week. So you can really kind of pull these things down on demand. It'll pull the picture right into the chat room that you're in, and it means that you don't necessarily have to go out. So let's say you get an alert about something. You could say, hey, what's my CPU usage? And it would kind of pull that right back into the room. So it's on its way back up now. So let's see. And if that fails, then I can pull back the history from another group, and you'll see all my test runs and that sort of fun stuff. So let's try that again and pretend that none of that happened. I should have tried something else first. There we go. OK, so that's what it was supposed to look like the first time if my Hubot instance hadn't gone AWOL on me. So we can do that, and then I'm just going to say, evolve-bot dd. So I allow for shorthand of dd for when you have 5 minutes left in a demo, or when you don't feel like typing Datadog every time. And say save that as API time. And then now if I wanted, I could say dd query 15 minutes API time. It's going to go, it's going to run that. It's going to run the same query, but it's going to tweak the time period. And again, you can do that as whatever you want. And then if we wanted, we can kind of come back, and I could say, we can run that for API calls here. So I'm going to pull up the JSON. I'm going to go back here and say evolve query that. I could say evolve bot, save that as API calls. So that's saved now. You could say Datadog list. It's going to say here are the API, here are the queries that I know how to do for you. You can delete them. You can interact. But and there are definitely ways to make it smarter. This is kind of a bare bones initial implementation. But the idea is that it didn't take that much effort to kind of create this almost conversational like bot instance where I just say query this, save it as this, delete that, show me what you have. And this is going to go out and reach out to, in this case, the Datadog API and say, get me the graph for this and put it right into this channel. And anyone in that channel can do it. You can interact with it. You can interact with it privately in the same way that you could with any other kind of Hubot instance there. And in the end, you can ship it. And I have 3 minutes left for questions if anyone has questions. But while I'm doing that, I'll throw my information up there again. Does anyone have any questions? She's running over with a microphone before you start talking.
Yeah, it's a two-part question. First is there any performance hits with that using any of the APIs? And second question is about any privacy concerns. With collecting user data, what can you collect legally? You need a switch for saying, hey, turn it off in settings, I want you to collect data.
Right. So for the first part, as far as performance hits goes, it kind of goes back to, like before I was willing personally to put this in any of the apps that I work on, I wrote up, like I mentioned, that Xamarin Forms app that profiled just the code that I wanted to do, because I wanted to see not just how quickly it ran on my own device or local machine, but if I ran it on some old crappy Android phone, would it really make the call a lot more expensive or something? So it's definitely something to keep in mind, where you don't want to degrade performance just so you can measure stuff, but there is a lot of low-hanging fruit there as well. For the second part about user data, this all has a caveat of I'm not a lawyer, so I'm probably the wrong person to ask about like what's legal and what you can do as far as user data. Generally, it's good to not store more than you need to. That's kind of the approach that I always take. Not having the data means you can't get into trouble for having it. So in general, it's good to try and store aggregated views of things or whatever is kind of useful. But if you don't have to tie users to certain things, then don't. But it also comes down to, like in the case of a lot of stuff that I work on, I am also the back end of this system, and we have that user data anyway. So in those cases, you do have ways to sort of tie things together. Yep.
Thanks for the information. Great stuff. Do you advocate or do you have a preference for any kind of models or frameworks? What comes to mind when I say this is smart frame GSM model? Do you have any opinion on that? Is there anything else that you recommend?
Anything outside of these products? I mean, I've used a lot out there. Like I use Raygun a lot at work. We use that for server-side stuff for crash reporting as well. They do have some real user monitoring stuff that they're rolling out. I've used Mixpanel a bit and Google Analytics. So they all, a lot of these services overlap a lot as far as the, in-app analytics and crash reporting and stuff too. So I definitely recommend kind of trying out a whole bunch. Definitely try out Hockey App too. But yeah, and it's worth kind of tinkering around and seeing what makes sense and what works well for the stuff that you're doing and what gives you access to the all of the type of data that you really want to use. And that just hit 0, so I'm going to be kicked off stage. But I'll be around for right after this and for the rest of the conference, so definitely flag me down, and thank you.